Welcome back, everyone. I hope that you had a nice break. We'll change the pace tiny bit. We will give the floor to our students. They have about 6 minutes per student for the presentation, and then we'll collect the questions at the very end of the session once all the students have presented their work. So, okay, we are ready to go.
Good afternoon. My name is Marn Schokker, and I'm a third-year technical artist here at Breda University of Applied Sciences. Thank you for attending my presentation about a MusicXML workflow in Houdini. So if you're anything like me, you love Houdini, and you wish its a procedural approach was used for basically any software. So here you can see how you would approach something in a manual music notation software like MuseScore, just modifying some notes. But this could, of course, be done procedurally if there was an importer and exporter for this in Houdini. So here you can see this is still manageable for small cases, but it becomes a lot more tedious when you have a lot of instruments or you have a really big piece of music. So this is the workflow I had in mind while creating my toolset. The start of all data is an exported file from your music notation software, like Finale or MuseScore. And I chose MusicXML because it's an open standard used by many different packages, and it's easy to parse because it's based on XML. It also contains a lot more data than MIDI, which will be interesting when we get to the visualization later. Using Python and the elementary library, I wrote an importer and exporter for Houdini with Python, as I mentioned. And this is then converted into geometry. It can be utilized in Houdini itself for visualization, but the data can also be manipulated and exported back into the music notation software. And all data is fully preserved. You mainly use SOPs to create selections on points, and then using Python and Vex, you can actually manipulate the data itself. And with this simple example, with just a few notes, I get the same result as what I presented earlier using the manual notation software. But this is done procedurally. And this does it for every instance of the melody in the music, which can save you a lot of time. And the power in Houdini lies in its visualization of the data. You can make data easier to understand by applying it to position, for example. And in this example, I've applied pitch to the y-axis and time to the x-axis. And if your music also contains loudness information or dynamics, you could apply that to the z-axis to give, it literally more depth. And for me, what's really interesting about Houdini is that it becomes really tangible. Like you can see all the data in the geometry spreadsheet, but you can also see it in the viewport. And by having the data visualized in 3D, you can use various methods for creating these groups I mentioned. So in this case, I wrote a simple HCA with the Python viewer state, which allows you to look for themes in music or like repeated melodies, which you can then perform actions on and import back into music notation software. And with the data in Houdini, the sky is really the limit as to what you can do with it. Here are two examples of a simple piano roll. So the one on the left, the colorization is based on the actual voice of the music, while the one on the right uses the HDA I just showed about detecting the themes. And one of the biggest challenges for me was figuring out how to translate the data from the XML structure into something you can use in Houdini while keeping all the data. For example, there's a labs node for importing map data, which I used for some of the inspiration for how to structure my Python code. But the issue with that, what made my approach more challenging is that I actually wanted to export it back into a fully compatible MusicXML file. So what's important to note here is the actual data I'm mainly interested in are the nodes themselves. So the nodes with the attributes are stored as points. And some of the data is then used for the point position, like I mentioned, the pitch and the time. And all the other elements of the XML structure that are related to, for example, how it's displayed on the score, are also stored on these points. And these points are connected into a primitive based on which voice they're in. And other XML header elements are stored as detail attributes. They don't need to be changed for every note, so that's why you can store it there. And the conceptualization of the export function was developed at the same time as the import, which made it fairly simple to develop this feature. And what's good about the MusicXML format is that it's text-based, it's XML, which makes it very easy to debug. You can just compare the input and output files and see where there are any changes or differences that you need to fix with your scripts. And Finale also has very verbose import errors, which made it very easy for me, or like helped me during development to figure out exactly which order to use. And the documentation of MusicXML has also been very helpful. To round off with, this is what the data actually looks like in Houdini. They're all stored as dictionary attributes, which makes it easy to parse with Python or Vex. And for some approaches, or like for some things, it's easy to do with Python. For some things, it's easier with Vex, but they both support dictionaries very well. Yeah, and as you can see, there's a lot of data to work with. So I think there are a lot of possibilities. And in the future, I'd like to finish packaging this project, so follow me on Twitter to get updated when this is released to the public. Thank you for listening.